So, in our last segment, we talked about a venue that should have had electronic acoustics and didn't get it. Turned out to be a very successful recital hall and small ensemble hall for classical music, but is pretty much unusable for electronic music and larger ensembles because it's just too loud, too reverberant. So if it had been the reverse, where the reverberation was turned on electronically and you could control the room for other applications, it would have turned out, in our opinion, significantly better, but it is what it is. So now we're going to talk about a venue, which is this one, that was presented to us as a challenge. This college wanted to build a recital hall on the second floor of a building, which limited the height of the room to about 12 to 14 feet total, including all the hardware that we had to put in. So a typical recital hall is 18 feet to 28 feet in height, and it also had very long, thin dimensions, very long rectangle. So there's a lot of things about the room that were not the appropriate way to go, not the correct way to go. So we had a meeting with the staff and talked to them about doing the room electronically so that we could control those parameters of the room. And the staff, being all classical musicians and opera folks, etc., were not real thrilled with the idea. So we discussed it. We talked about the limitations that if we did a physical acoustic treatment only, which is how we started out, that we would be limited to making the room diffuse, which means making the sound seem like it's not coming from walls and ceilings that are as close as they are. But the reverb time and other frequency parameters would be completely limited by the actual physical dimensions of the room. So we managed to get the entire music department to come out to a venue we had done with a relatively basic electronic system. They brought their own people out, performed in the room, got to listen to the various iterations of the system, and all but two of the staff were very pleased with the results. And they decided to let us go ahead with implementing electronics as part of how we designed this hall. So looking at the way we went about this, once we had that determination that we could go electronic, first thing we decided to do is how do we make the ceiling seem like it's not 12 feet in the air? And you can see here, this is door height. This is 7 feet. So we got a very limited height. This product is a fiberglass formed product. It's a very hard material that breaks up sound using some math that somebody else developed. It's nothing that we did. It's RPG Acoustics that developed this product. We've used this in a number of venues, and what this does is the sound that's hitting the ceiling that would normally reflect right back down and give the people in the seats the sense that there's a ceiling 12 feet over their head. This diffuses sound down to a low enough frequency that it really gives you the sense, if you close your eyes, that even without the electronics on, that the ceiling is considerably farther away than it really is. These side wall elements that were used also are diffusive. And you notice the various patterning. This was done to try to minimize a whole bunch of effects you get if they're all facing the same way. So the modulation between them is controlled by the patterning. And then on the backstage, we created a three-dimensional absorptive system to control reverberation in the room. And all of these things together basically take the room and make it seem further away, soften the sound, and they're also used to tune a bass reverberation characteristic that allows you to raise and lower it without it sounding extremely artificial. Now, the way we actually do the reverberation control is with a whole series of loudspeakers spaced throughout the room, sidewalls, overhead. Some directional loudspeakers that are used for sound reinforcement are also tied into the system. You can see, the little elements. You don't even see them when the lights are off. But throughout the room, we've got this large number of loudspeakers. And if you look at this flow diagram, these are the overhead reverberant field loudspeakers. And they're tied back to an array of microphones that are embedded over the stage and processed through all of these digital processors to create the effects that we're looking for, or the room acoustics we're looking for. And then back on this page, you've got these side early reflection loudspeakers, subwoofers, primary and delayed main loudspeakers. And then you'll notice in this, if you looked at it carefully, which I'm not letting you because it's not zoomed in far enough, but let me just tell you what these are. So we had a DigiDesign console as a main console that was requested by the sound reinforcement folks. And then there's a Yamaha 2000 series digital console that was desired by the electronic music department for some uses of the system that they had through Dante. And they enjoy the way Yamaha does their interfaces, so they asked for that as part of this. So what we've got here is a room that has total electronic acoustics control for live performances, so that if you're doing an opera piece or you're doing a jazz trio or whatever you might be doing in this room, you can create the environment you want for those performances. And then on the electronic side, they have the ability to address every one of the loudspeakers in this room individually through Dante. So the electronic music department creates these massive soundscapes with moving elements and speakers where there may be a saxophone coming out of this and a vocalist coming out of this and something else coming out of here and something else coming out of here, and it's all able to be manipulated in real time during a performance. So this is all run through all of these digital processors, individual amplifiers that are driving each loudspeaker so that every loudspeaker can be individually tuned for the electronic music use as well as individually tuned for the early reflection and reverberation use of the room. So that's all pretty cool in and of itself and makes the room extremely multi-purpose. The people in the department, when it was finished, and we had our jury, which is what this is, people from the department, people from the factory, in this case Yamaha's the product that we were using in the room, and people from the contractor and other interested parties, and just random people who walked in off the street. Everybody got a chance to listen to it and was extremely pleased. So that by itself is pretty nice. The other aspect of this, however, is something else we were tasked with, which was real-time teaching to overseas locations. So this room is tied to any place in the world through dark fiber high-speed interface. We've got HD cameras that are both installed and portable where they can use operator-based cameras. So you can put 2 or 3 cameras up, put an ensemble on stage, be performing with or teaching back and forth with, let's say, Vienna, which they do, and all of this done in almost real time. The great part, though, is the far end information that comes back to the stage is also able to be processed through the electronic acoustics in the sense that they're already in the room. So you've got the ability to match the acoustics of the far end, whatever venue they may be in, with your venue. So if they're in a room with a really big stage and all sorts of nice acoustics, and your room, if it didn't have electronic acoustics, would be this really small sounding space, you can dial this up to sound like whatever you want it to sound like. This is also a real advantage for students who are creating their recital pieces or their jury pieces. There's a pair of stereo microphones embedded somewhere up here in this area that hear the stage for recording. But let's say you're recording something where you really want a much bigger environment. Turn the electronic acoustics on, that stereo pair of mics hears that room. So instead of having to get the recording studio across the hall, which there is a multi-track studio across the hall tied to all of this, instead of having to get them involved with engineers and extra personnel, a group of people can come in, set up their performance, choose their acoustics by touching the touch screen and saying, this is the reverb curve I want, this is what I'm looking for, and then just record it with a stereo pair and walk away with a really nice performance that, as long as you didn't shoot video of it, they won't know what room you were in. They might think you were in the big performance hall, which is across the hall down an elevator and on the other side of the building. So they would hear what you heard, and it allows students to do their work without a lot of involvement from other departments. So anyway, that's kind of a summary of this venue. It's made it extremely successful, extremely multi-purpose, and this is just one of the applications where electronic acoustics is a huge bonus for people that are looking to create a multi-purpose environment.